Hey guys, this is Mr. Grice for Algebra Unit 10.1. Today we're talking about linear correlation is the beginning of our new unit, all on statistics. Our learning target today is to be able to identify the types of correlation and the correlation coefficient of a set of data, and to be able to recognize if correlation signifies causation. So, first thing we're going to talk about is a scatter plot, a scatter plot, which is a graph that compares two variables by using scattered and disconnected points. Okay, so hopefully you've seen these types of graphs before. Okay, you can see how the points aren't always or they're not connected, but you can kind of see the general trend of what's going on in most cases. This is called a scatter plot. Okay, and guys, if at any time I'm going too fast, please pause the video so you can get the definitions. Now, a correlation is a relationship between two variables. Okay, right now we're just going to be talking about X and Y, but later we will be talking about real life examples. And then lastly, linear correlation. Linear correlation is a correlation that is linear. And you guys know that linear pretty much means it makes a line. Okay? So in example A, you can see that it is a line going up, okay? And B, it's going down. And C, there's like, I have no idea what's going on, okay? So, types of linear correlation, okay? And we're gonna use the above graphs to show. Positive correlation, like example A, the points in the scatter plot form a linear pattern with a positive slope. Okay, you can tell that this is positive and it's going up. Now, example B is a negative correlation. You can tell that that's going down. So the points in a scatter plot form a linear pattern with a negative slope. And example C is one of no correlation, okay? And when we have no correlation, it means that the points in the scatter plot do not form a pattern. Okay? So guys, I know the hard thing about a new lesson is all of the vocabulary, so please make sure you're copying all of this stuff down, and then if you have questions, to come talk to us. Okay? Now, the correlation coefficient is a number that represents the strength of a linear correlation between points. Okay? So, we have strong, negative, moderate negative, and weak negative, and then weak positive, moderate positive, and strong positive. So, at -1 right here, this is a perfect correlation. And all the way over here at +1 right here, this is another example of perfect correlation. Okay? Now, this might be a little bit confusing. So if you want to write it in a different way, let me show you. So we can have perfect correlation, okay? And with perfect correlation, it's always going to be 1. Whether it's a +1 or a -1, that determines on the graph, okay? So if it's going to be strong correlation, that means it's going to be between 0.8 and 0.9, okay? Or just, well, let's just say 0.9. If it's moderate correlation, it's going to be 0.6 to 0.8, somewhere in between that range. Okay, weak correlation is going to be somewhere between 0.1, and 0.5. And then no correlation is going to be 0. Okay, so this is just another way to look at this right here. Okay, so if you want to write this down, pause the video and so you can copy it down. Okay, now let's get back to here. They want us to estimate the correlation and the coefficient and describe the strength of the correlation. So look at number 1. What do you think? Okay, now if you guys ever want to draw a line, a best fit line, you can do that. So I'm going to draw a line. See how everything is pretty much right there, all on top of each other? What that means is it's perfect. Okay, everything makes a perfect line. So the variable we use is r, and we would say that r is 1. Now, look at 2. So 2, once again, I'm going to kind of draw a line. And see how all those points are very, very close? They're not always in the right spot, but it's very, very close. What that means is that is strong correlation, okay? A strong positive correlation. And then we would need to say, what number is it? And over here, we said that a strong is 0.9. So if it's a strong correlation, that means my number is 0.9. And we're drawing the squigglies because we're estimating, okay? All right, number 3. Once again, I'm going to draw a line that goes right there. And see how the points are getting farther apart? The farther apart they're going, that means my correlation isn't going to be as strong, okay? And this is an example of moderate correlation, okay? For moderate correlation, if you want to look right here, it's between 0.6 and 0.8. So what number is in between there? 0.7, okay? And then the last example that we're doing on this page is 4. So I'm going to try to draw a line. We can see the general trend that everything's going up. Now, the points are getting farther and farther apart. Okay, there is a correlation to this, but yeah, guys, it's a very weak correlation. Okay, so this was our strong. Here's our weak, and then we had example of moderate. Okay, and for weak, it needs to be somewhere between 0.1 and 0.6. Same thing over here, somewhere in between there. And I'm just going to pick the number that's right in between, which would be 0.3. So 0.3. Okay, let's flip it over. So now they're asking us to do the same thing, except now all of these ones are negative. Okay. So our first one, what do you guys think? Well, it looks like all of them are, yeah, it looks like all of them are in a row. Okay. Which means that 1, that's going to be -1, and it is perfect. Okay. It's a negative because our slope is negative. Let's look at 6. Okay. Once again, I'm going to draw my line. Sorry guys, I don't have a ruler on me, but you can see that all of the numbers are extremely, extremely close. Okay, so that means that it's a strong correlation. And we need to estimate a strong, we said that strong was 0.9. All right, number 7. Once again, we're going to draw our line that kind of goes in between everything, and we can tell that the points are, some are close, some are far, some are close, and how it's going back and forth. Yeah, there's correlation to that. It's not strong, it's not weak, it's moderate. Okay, it's somewhere in between there. And we said for a moderate, first off, it's negative because it's going down, was about a 0.7. Okay? And then the last one, 8. I'm going to draw my line just so I can kind of see what's going on. Now, overall, they're going down, so I know that it's negative, but is it very organized? Nah, man, this is weak. Okay, so if it's weak, I know that it's negative and it's going to be about 0.3. Okay? So just know that those numbers, the negative 0.9, 0.7, 0.3, we are getting those all from over here, okay? If you have a perfect graph, your perfect should be 1 or positive 1. If you have a moderate, your number should be between those two numbers, okay? All right, why don't you guys try 9 through 11, all right? It says for each scatter plot, match the correlation coefficient with the corresponding scatter plot of data points. Describe its strength, okay? So tell me, is it weak? Is it strong? Is it moderate? Is it perfect? And then write A, B, or C, okay? So go ahead and pause the video and good luck. Okay, and there you go. So for number 9, we know that it is positive because it's going up, but it's weak. Okay, so out of these 3, which one was positive and weak? C, 0.4. Okay. For number 10, this time everything's going down, but once again, it's not real close together, so that's a weak correlation, which means that's why it's the negative 0.3. Okay. And B, we can tell that they're going up, but they're getting, the points are closer together than they are for C, so that's why it's a moderate. Okay, and that's why we use the higher number of 0.7. Okay. Well, guys, I'm going to stop the video right here, just so it doesn't get too long. And video number 2 will be all about correlation versus causation. This is Mr. Grice signing off for Algebra Unit 10.1 Notes, Video 1. Thanks for watching.